Ladies and gentlemen, it's Tuesday. Everybody's bummed. It's supposed to be a storm day. It's not. So we all had to get our butts out of bed. Our parents came into our room. We thought they were going to say it's a storm day, and lo and behold, only half the island gets to miss school today. So we're here. We're learning. We're doing our practice test on polynomials. The first 6 questions are true and false, and the first question says the expression 2xy squared has a degree of 2. So in order to first start this question, you have to know what a degree is. So the degree is the sum. This is the degree of a term, not the degree of a polynomial. The sum of the exponents within a term. So fortunately for us, 2xy squared is just a term. And if we think about the exponents, 2xy squared is actually equal to 2 multiplied by x multiplied by y multiplied by y. That's what it means. The exponent on the 1 is actually, or on the x is actually a 1, which means the sum of the term 2xy is actually 3. So therefore, we can say false. It's 3. And then you can show right here, 1 plus 2 equals 3. Something like that would be totally okay for your work. The second question says combining negative 2x squared, combining means addition, with 2x cubed plus 1 will result in a binomial. Well, the answer for that is false, because this term and this term are not like terms. So if I was to gather like terms, I'd start with the highest degree term, which would be 2x cubed, minus 2x squared, plus 1. Therefore, when I combine them, there are no like terms, so the combination of that monomial with that binomial, because there are no like terms, will simply result in a trinomial. Question 3 says 4x plus 3 is equal to this big long chain of events. So what you really needed to know was, I'm going to take this chain of events and gather like terms. So some of you like to box it up. It helps to see them better. Some of you like to model. That's okay if you do that, but eventually you want to get to the step where you don't have to model it. Look at my highest degree terms first. Those are my x squared. A positive 2x squared and a negative x squared and a negative x squared. Those are your x squared terms. That's going to combine to make nothing. So those are gone. My 4x is going to combine with nothing else, leave me with 4x. And a positive 2 and a positive 1 makes a positive 3. So therefore, true. When you gather like terms, you end up with 4x plus 3. Questions? Question 4, the sum, meaning adding, of the two polynomials is a monomial. Same thing as before. When we're going to add them, we're going to actually gather like terms. So those two there are going to add up to be 8x squared. And a positive 1 and a negative 1 make 0. So we just have 8x. So therefore, question 4 is also true. When we add those two binomials together, we end up with a monomial of 8x squared. Question 5, when x is 3, then this one will be greater than this one. So all it asks you to do is substitute 3 for your x and simplify using BEDMAS. So 9 take away 1 is 8. 12 take away 6 is 6. Is 8 greater than 6? Yes, it is. And therefore, you would say true. When x is equal to 3, and I substitute into my two expressions, the left expression, the left binomial will work out to be 8. The right binomial will work out to be 6. And therefore, it is true. Question 6, the sum of an algebraic expression and its opposite is 0. This is true as well, and we talked about that a lot. So if I take any algebraic expression, for example, the simplest one we know, which is x plus 1, sum being adding it to, the opposite expression, the opposite of x plus 1 will be a negative x minus 1, because the opposite of this is negative x, the opposite of this is negative 1. Those are opposite expressions. This plus this will make 0. This plus this will make 0. And therefore, you will always have 0 when you add an expression to its opposite. Any questions on the true-false? Question 7 says rearrange these terms in the polynomial in descending degree. So we have 1, 2, 3, 4, a 5-term polynomial. Are any of those 5 terms like terms? Thank you. No, they're not. So we're going to look at degrees. If I think about degrees, I'm just going to write the degrees of 0, degree of 2, the degree of 3. Why is it 3? Because each of those variables have invisible ones. This has a degree of 4 because 2 plus 2 is 4, and this has a degree of 1. So now that we have the degrees written, it's a piece of cake. Descending means from largest to smallest. So our first term is this. Now notice how I still have the negative sign there, right? It's not a positive 36xy squared, it's a negative. So you do need to include that as your first term. Then a comma, that's a first term. Then a positive 4xyz. Do you need the positive sign? No, I just put it there. Then we're going to go to negative 2x squared. Do you need the negative sign? Yes, you do. Then negative 10y. Do you need the negative sign? Yes, you do. And finally, your last degree, a 0 degree term, is 4. So that's the order. A lot of people screwed up here. They thought that this term just had a degree of 1, but remember, it's the sum of the exponents on the variables within the term. So therefore, that's a degree of 3. Question 8 says gather like terms. So now we have a 6-term polynomial, which we can gather like terms. Please gather them in descending degree. So if I look at the degrees here of the 6 terms, the term with the highest degree is this one, has a degree of 2, but there are no other like terms for that. So that's all I'm going to get when I start with that term. A 3x and a negative 3x make what? 0. And a positive 4x will remain. And a negative 1 and a positive 1 make 0 as well. So when I gather like terms, I end up, it was a 6-term polynomial, but after gathering like terms, I end up with the binomial 2x squared plus 4x. Question 9, same question, just a little bit longer. If you like to box it up, go ahead. You don't have to. Usually helps people. Of those 7 terms, which degree term has the highest degree? X squareds. A negative 3x and a positive 3x make 0. A negative 2x and a positive 2x make 0. A 10, a 5 make 15, and a negative 15 make 0. So when you gather like terms in number 9, you end up with nothing. Okay. Question 11, find the sum. X and 3x make 4x. Really what you're doing is you're keeping the term x and just combining the coefficients of 1 and 3 to get 4. And a negative 4 and a positive 5 make a positive 1. So therefore the sum of those two is 4x plus 1. Question 11, add again. So this time, I'm not going to gather my x's first, am I? What am I going to gather first? My x squared, because it's my highest degree term. Does it combine with anything? No. Is it a positive or negative? It's negative. So when I write down that term, I'm going to write a negative 5x squared. A positive 2x plus a negative 2x makes 0. And just a positive 3 is all I have left. So that binomial plus that binomial leave you with that binomial. Question 11, simplify is a fancy word for gather like terms, which is a fancy word for add, which is a fancy word for find the sum. Anyone works. I'm adding this binomial to this binomial. The first one I'm going to gather is my highest degree terms, which is my x squareds. That's done. Now I have a degree of 1 here and a degree of 1 here. When you are left with degrees of 1, just gather the alphabetical variable first in alphabetical order. So I'm going to gather the x's first because they come in alphabetical order first. So plus 10x will be my next term. Plus 2y will be my next term. And finally, minus 3 will be my third term, my fourth term. Find the difference. Now, for question 13, what is the easiest way for us to find the difference? Carl, what's the easiest way to do this? Modeling it? No. What would you do? You're not sure. What would you do, Ely? Keep flip changer, add the opposite. So if we think back to grade 7, and we did this now a number of times, if this was the question in grade 7, you could have modeled it. You could have said, I have 2, and I have to subtract negative 3, but I don't have any, so I add zeros in here. And then I subtract negative 3, and I end up with an answer of 5, right? We learned to model it, but then we learned the easiest way to do it is keep, flip, change, and I get the same answer without having to do all that rigmarole of modeling. The same thing is true of polynomials. Keep your first polynomial, change to addition, and use the opposite this time, not of the first term, but of the entire polynomial. So this is going to become a positive 2x, and that's going to become a minus 1. Now that we have that, we're going to gather our like terms. Those two make 12x. Those two make negative 5. And when I find the difference between those two, the answer is 12x minus 5. Okay? Any questions with 13? Same thing here. Keep your first polynomial, which is a trinomial this time. Change to addition and use the opposite of the second polynomial. So it's going to be a positive 10x squared, a negative 2x, and a positive 1. Gather like terms. That and that make 20x squared. That and that make negative 4x. And that make positive 2. Question 15 is our really small baby addition pyramid. It says, what addition or subtraction equation can be used to find the missing polynomial in the addition pyramid? What is it? So this brick plus this brick equals this brick. So our statement will be this. This is worth a point on your test. That's the addition statement. Now that I have that, this plus this equals this. This is by itself, and this is by itself. So therefore, we have the trinomial of x squared plus 5x minus 3. Same question for 16. The only difference is it's no longer going to be addition. And what we did when we did our practice test is I said, a strategy you should always use in questions you don't know what you're supposed to do is think of an easier one. If I had this, just not polynomials, but just straight up numbers, what's the missing number? 2. What operations could I have used to get that? Subtraction. I take this one, 5 take away 3 equals the missing one. Well, since we used the strategy of think of an easier question to solve it, the same theory should work here. This one take away this one should be this one. So our answer is this trinomial take away this binomial will equal the missing one. Keep, flip, change. Keep, flip, change. I end up with that. 4x squared is gathered with nothing, so I'm just going to put 4x squared. Negative 2x and negative 2x makes negative 4x. And positive 1 and positive 5 make positive 6. So that is your missing trinomial in that particular pyramid. And don't forget this strategy. It's really important that for any question you're having a hard time thinking about what to do, think of an easier question with easier numbers, rationalize how you would do it with easier numbers, and it should help you solve the actual question. Question 17 says model to solve. So we have an x squared. We have a positive 4. We have a negative x squared. We have a positive 2x. And we have a negative 1. So if you wanted to put brackets around it, you can. It doesn't matter. If you want to put a plus sign in there, you can. But that's basically what it says. This plus this makes nothing. 2x is left by itself, taken care of. 4 positives and 1 negative make 3 positives because that and that make a 0. And you end up with 2x plus 3 as a solution. Model to solve. This time we have subtraction. So I'm going to start with my space here and start with my first polynomial, which is this. And from this polynomial, I have to subtract all of this. Well, looking in that space, I don't have a negative x squared, but we know that by placing this in there, I still have an x squared plus 4, even though there's other things in there that other thing is worth nothing. But now I can remove a negative x squared, so I'm going to remove it physically from space. When you remove a negative x squared, you actually increase the value by a positive x squared. And I'm also going to remove a negative 1. Don't have it, so I'm going to add a 0 pair. Remove that negative 1. Removing a negative 1 increases the value by a positive 1. That final solution is 2x squared plus 5. 1 squared x squared, 2x squared, plus 1, 2, 3, 4, 5. Is this the last question? Question 19 says, what expression could be used to find the missing side? I'm shocked at how many people couldn't figure this out. But if you use the idea of the easier question, so this perimeter, let's just make it 20 instead, just for poops and giggles. And let's make this side 4 and this side 10. If the perimeter of the triangle is 20, and that's 4 and that's 10, what's the missing side length? 6. How could we have gotten 6 from an expression with the easier numbers? We could have done it two ways. We could have said 20 take away 10 take away 4 equals the missing side of 6. Would you all agree with that? The perimeter, take away the two sides we know, equals the side we don't know. Or 20 take away 10 plus 4 equals 6. Would you agree with that one? So from an easier standpoint, both of those work. But let's now plug in, instead of using simple numbers, let's use our perimeter, bracket, take away side 1, take away side 2. That's the exact same thing as this, isn't it? Right? So that should equal the missing side. Keep, flip, change, all of them. So keep, flip, change, keep, flip, change. We good on that? Now we gather like terms. Gather our highest degree terms first, which is this one. We're going to have a negative x squared as our first term, because there's nothing it's going to combine with. A 6x and a negative 3x and a positive x. Does that make 4x? Yeah. Plus 4x. And a negative 1 and a positive 2. That's a positive 1. And a negative 5. A positive 1 and a negative 5 make negative 4. So our solution is that. So the first thing is this. What expression could be used? We're just going to take this one right here. That's our expression that can be used. What polynomial represents the missing side? That polynomial represents the missing side. And finally, if x equals 3, what is the actual lengths of all three sides? So if x equals 3, what's this side right here? 9 minus 2, correct? Which is 7. So this side length would be 7. If x equals 3, then 3 squared minus 3 plus 5 is 9 minus 3 plus 5, which is 6 plus 5. This side would be 11. Agreed? And this missing side here, we actually know it's here. So if x equals 3, the opposite of 3 squared plus 4 times 3 minus 4. What's the opposite of 3 squared? Anybody? That's right, negative 9. Thank you all for volunteering. You're wonderful today. Negative 9 plus 12 is positive 3. And even though it's impossible, what is this, the length of this? The length would be a negative 1. Okay? Even though it's impossible.